Hi everyone, my name is Leon. Thank you for joining my presentation. This is going to be about performance testing in the cloud with Locust. So I work at the Bol in team 25E, and we have quite a few applications, some of which are pretty critical for the logistics operation. And last year, before we started the peak season, we wanted to make sure that these applications were ready for the increased load that we expected during the peak. So we did some investigation and we ended up using Locust for the load testing of these applications. So today you won't see any slides. This is going to be like a live demo all the way. I'm going to show you how things work and also how we actually got our performance testing deployed via R2D2 to the Google Cloud environment. So let's get started because we have a lot to do in this half an hour. What you're looking at now is the website of Locust. Just to give a short introduction of what Locust is, I think this the first few lines you see here say it all. It's an open source tool, which of course is also always nice. It works with Python. You use Python to write your test scripts. We will show some examples of that in this presentation. And just at the bottom here, you see like a screenshot of the web UI that you can use for Locust testing, which we will also be using. So I have Locust now running locally on my laptop with Docker. And this is what you get. You see like a nice interface, start a new load test. You can input a number of users to simulate. You can have a spawn rate to determine how fast these users pop up when you start your test. And you fill in the host of the site you're going to be testing. So for this presentation, I didn't actually tell the organization yet, but I'm going to be testing the Spaces Summit website. Don't worry, organization, we'll keep the load very, very low. We don't want to DDoS anything today. Well, let's see how this works. So just to keep friendly faces in this room, I'm going to start one user. And I have a test script set up, and you'll see what this does. So in here, on this page, I hope this is zoomed in enough. I can zoom in a bit more. Just so you can all see it properly. You see that there are two pages being visited, the index.html and the schedule.html. So you have some nice statistics here, the number of requests that were sent so far, how many failed, and of course, very important for a load test, how fast did the pages respond. And then there's at the top also some interesting values. So here we see we have one user running. That's fine, that's what we configured. There's also one worker. We'll get more into what that means later. And we see the requests per second, so 0.6 requests per second. Well, let's do a little test. What if we have two users? I think you would expect two users to have like twice as much requests. So right now we see it at the request per second at 0.6, 0.7 sometimes. So we'll stop it, start a new test with two users, and see if that request per second increases. We would expect so, right? Just to verify this. Yeah, so now we see at the top that the request per second is 1.5, actually a bit higher than I expected. I would expect 1.4. I had it going down. That's fine. There's a bit of randomness in the user test, which can explain why the values sometimes differ a little bit with what you would expect. So you've seen the GUI. Let's see what this test script looks like. I'm going to stop this test now. And we are going to visit some code. Not this one. This one. So I've also zoomed in a bit on my IntelliJ. I hope that's all the code is readable. This is the test script that we were running. So this is a Python file. you can see at the top, we just import some stuff from the Locust library. We have some default headers because we want to simulate like being a web user and visiting the actual website. So we want to pretend we're on a browser. And then there's a class defined here, which is called Spaces Summit User, which is a name that I gave it. But what's actually important is that it's a HTTP user. This is the Locust term. It means that this user can do HTTP calls, simple as that. So a user in Locust can have several tasks, and it will perform a random task, wait a few seconds, milliseconds, whatever you configure, and then perform another task at random. So you can have as many tasks as you'd like, and it will just pick a random one each time. So in this case, we see a wait time defined of between 1 and 2 seconds. That's the randomness I was talking about earlier. And we have 2 tasks, the get index and the get schedule. And to make it, I told you it will pick one at random, but to make it a bit more controllable, you can assign weights to these tasks. So in this case, you see here, task 1 means the weight for the get index is 1. For the schedule, the weight is 3. So every time this user picks up a new task, the chances are 3 times as high of going to the schedule page than it is going to the index page. And really, that's it for this test. You don't see any other code. It's very clean, very simple. And to be honest, this is also what the tests look like that we actually use for our applications. Yeah, we are testing APIs with my team. So we're just testing a few endpoints and increasing the load, and it can be as simple as that. You could imagine it being a bit more complicated if you're actually if you would want to test the bulb.com web shop. You probably have a few more actions to take. That's all possible. I mean, this is a Python script. You can import any Python libraries you'd like, and a task doesn't have to be an HTTP call. It can be like anything really, as long as it's doable in Python. Just for this presentation, I will stick to the simple case of testing some endpoints. What you may notice is that there is no async await when we do these REST calls. There is no callback hell that you could get into. This is really a synchronous process. And this is a strength of Locust because it keeps the test really simple. You could also consider it a weakness because how am I going to create this large amount of requests if I can't do it asynchronously? If I have just I have a single container firing these requests now, increasing this load, and it's a synchronous process. How can it compete with other tools? I don't know, you have other performance testing tools like JMeter, Gatling, that can use asynchronous processes. How can it compete? Well, the answer lies in the distributed environment that we run Locust on. So where a different tool might have like one service firing a huge number of requests at our application at the same time, synchronously. Locust will have several services all doing one thing at the same time, but together they can compete with the asynchronous process of the other service. So let's take a look at the Docker file to give you an idea of how we could scale up the number of services. We have here the services defined. We have one master and one worker. Both are built on the same Locust image. Pretty peculiar. So you have to tell the image itself, are you the master or are you the worker? We do that in the arguments provided here, master or worker. You provide the test file, which is called locustfile.py in this case. And for the master, you supply a port number, which is used, I can show you again on my, so the port number is used to access the web UI. And you tell it which host you're going to be testing, just so it can pre-fill that field. And as for the worker, you just tell it which node, which service is the master node, so it knows where to send the results. Because what will happen is the master is like it orchestrates the workers. It assigns the tasks to the workers. The workers will actually do the REST calls and will send the results back to the master, who then shows it on the web UI. So you could imagine this scaling up by just having multiple instances of the worker when there's always just one master. We can demo this, of course. So normally you would start Docker with the Docker Compose up, but in this case I will scale up the number of workers to 2. And you see now that it's attaching to worker 1 and 2. I'll go back to the example. And now you see at the top here that there are 2 workers ready to perform tasks. So let's also add 2 users. There they go. First thing to notice is that the number of requests per second is actually the same as when we were doing this with 1 user. It's not like increasing the number of users automatically increases the load. It's just that the master delegates it between the 2 workers, which means that if at some point you are hitting a limit of how much load 1 worker can produce, then it makes sense to add another worker so they can share the load. We have here a worker tab. I noticed I didn't show you all the other tabs. It's something they have some nice charts in there. I won't go into that for this presentation, but be sure to take a look at that when you play around with Locus yourself. But there's this worker tab, and it now shows the 2 workers, both with 1 user. So just to give you a better idea of how this works with the workers and the users, if I just have 1 user, and I have 2 workers, then 1 worker will actually not be doing anything. As you can see, the number of users for the top worker is 0, so it makes no sense to have this kind of configuration. All right. If you have like a low enough node that really 1 worker would always be enough, you could also consider running it like without the master worker setup. And Locus has this feature called standalone. So if I just start the master node and I remove the master argument, so it now no longer knows it's the master, Locus will default to a standalone setup. Let's start it up again, just the normal version. And now you will see that at the top, you no longer see how many workers there are because it doesn't use like the workers anymore. The master does everything. There's also no more worker tab here. So if you have just a limited amount of load that you want to generate, this is also an option. It might make your configuration a bit easier. All right, for now, that's it for the introduction of Locust. It's time to dive deeper into how am I going to get this performance test running on the bol.com cloud using our toolset like R2D2. This was a bit of a challenge for us when we started, but we figured out a nice way, a way that we like to work with it. So this is an example of the load test that we use for our application Waco. And you see it hosted on staging, Waco performance .staging.bol.io. So we can just fire our performance tests whenever we like from the cloud. Just to, Waco can handle a bit more, right? 10 users. To give you an example of what that looks like. You see, we have currently 2 users active on Waco, 2 workers, sorry. Probably overkill, we don't really need it, but it was nice playing around with Locust a bit. And you see we are just testing 3 different endpoints. This is probably not the prettiest test you could have. We have for a different application for Zelda, we have a bit more like complicated test scripts where we use different identifiers, and we can prettify the name a bit here, so you don't see these URLs, but you see just like a semantic description of what you're testing. For the sake of time, I'm going to not go into that too deeply for now. Instead, I'm going to dive deeper into the code again. So let's take a look at the Waco performance project. Here it is. Okay, I see the left side project is not really zoomed in, so I hope you can read it, but we have a few directories here. One is called Docker image, and that's actually when we build the Waco project, the Waco performance project in GitLab, it will build this Docker image and push it to our cloud environment, so we can use it, and that's like the Locust image. And we have some templates that we'll get into later, and some GitLab. But first, the Docker image. It contains a list of requirements, and these are just like your dependencies for Locust. Right? So we are running on actually not the newest version of Locust currently. Still need to update that. And you have some dependencies here, but updating this is as easy as just changing the number here. And then this image also contains the Locust file, the test file. In this case, we've called it tasks.python. Zoom in a bit. So you see this is very much the same as the test script that we showed earlier, just the user waiting a bit, in this case a constant time of 1 second between requests, and some task with some wait. That's simple. Well, let's take a look at the GitLab file. We've used Locust for several of our applications. So we've tried to make it as generic as possible so we can use the same code for several applications. So that's why we have some variables here for our project, for the app name, for instance, is Waco in this case. And these variables are being inserted into the template file that we use for each of our applications. I'll show you that in a moment. First, just a moment to look at the container build step. Here you see that we are submitting our Docker image to the cloud, to let's see, to our project, and the Docker image that's being uploaded is actually the one that's in our directory Docker image. For the deploy to staging step, this is where the stuff happens that I mentioned, where we use the variables. There are some placeholders in the templates. They use the double brackets, double accolades. So here the template app name is being replaced everywhere in the template with the actual value in the app name variable. So Waco is being, as a string, being inserted into this template. So we do this for all the variables in both the master and the worker file. And at the end of the step, we apply this in Kubernetes and we roll out the deployment, because these template files are actually deployments. We'll take a look at it now. I have the master open here. So this is a Kubernetes deployment. You see these placeholders that I was talking about. And what's important, it's not very readable because of all these placeholders. Let me just point out the most important part. Well, if you're using the newest version of R2D2, you will need to define your service account name here because of workload identity. You see that the master is like here is the Locust node is set, Locust mode, sorry, is set to master. The target host is set to the Waco application here. And we have several ports. The top one, 8089, of course, for your web UI, and the other two are for communication between master and worker. Well, there's some more stuff here, but I'm going to skip over it for the sake of time. And I'm going to show you the R2D2 infra that that goes along with this. So this is the part of the Waco infra that's important for these performance tests. Here's the service account that was used in the deployment. There's a service endpoint which exposes the ports that we use. Again, you see here destination port 8089. You see the ports used by the workers and the master for their communication. Also had to name this one Waco Locust Master because that's the name that the workers search for when they want to connect to the master. And then there's some stuff like a user endpoint and the authorization policy that we use to get Waco running on Waco performance.staging.bol.io. Not that complicated actually. It took a little time to figure out, but it works fairly nice now. So let's take a look at what this looks like in the cloud. So these are the pods running for Waco on staging. Let me see if I can get this readable for you guys. Yeah, there's a lot of pods here actually for Stanley and stuff, but what's important are these two lines. Yeah, so we have a Locust master and a Locust worker. There's actually just one worker, so Locust was lying to us earlier when it said there were two workers. I'm not sure about that. Something with probably needs a restart of the master before it recognizes that there's just one worker. But we can actually scale these workers like real time. We don't have to restart the application for it. We could say kubectl scale deployment Waco Locust worker. And the number of replicas is, well, let's make it 3 in this case. So it's now scaling. And yeah, we see we still have one master, but there are 2 more workers now added. And it will immediately, we will immediately be able to use it. I just switched back to the top where we have our performance test, and you see here we have just 3 we have already 3 workers here that we can use. Just to verify, start. Let's take a look at the worker tab. 1 worker is missing. Well, at least we know. Let's not get into why this didn't work now. Probably has to do with why it thought there were 2 workers in the first place when there was only 1. It's a demo effect, right? Something always goes wrong when you live demo. That's fine. We could probably just restart the master and workers and it would be fine. Well, we have 2 minutes left, so let's actually do that. Just well, I'll restart the. I'll probably need to restart the master. And just restart the workers as well, just in case, you know, when all else fails, did you try turning it off and on again, right? There are probably some Kubernetes gurus like getting headaches from me typing out every command without any aliases. That's fine. I'm still learning. See what's happening here. It's recognized 1 worker. Still stuff happening. Not enough time to actually check it now because looking at the time, it's time for your questions. So I'm going to leave it at this. Thank you.
All right. Thanks, Leon, for your cool demo. I see a lot of great interaction in the Google thread, but also some questions on Mentimeter. So let's see how much time we have, right? We have 5 minutes to answer them. So first, how would Locust tests fit in our continuous delivery?
How would they fit in our continuous delivery? Yeah. I think I get the question because right now we're starting our tests from the web UI, and you might want to run them automatically, like after every change. And that is possible. Locust has a headless function option. What do you call it? I didn't explore this myself yet, so I can't go too deeply into it, but you can run it headlessly, so it automatically runs your test and then shuts down again. I hope that answers the question.
We don't have the people here in the audience, so we don't have the reaction of yes, but let's hope that they are at home thinking yes. So the first question actually came in at what RPS does the Spaces Summit site break? Crew already said that it might be a lot of work, but maybe you have a guess?
No, let's not. I'm in a room here with a lot of people who will get very angry at me if I try. So.
All right. Is the project available on GitLab, Leon?
Yeah. There is the Locust project, of course, which is open source, and the projects that we use are performance tests called Waco performance, but we also have for our other applications Zelda performance, Kappa performance, and there is one performance testing repo in our team GitLab space for 25E. They are available. I can maybe share some links after this presentation in the Spaces Summit chat. Yeah, you should be able to access them.
All right, great. That's helpful, I think. So we still have time. So I just go through the questions that are still here. So next question. In Team Libra, we encountered CPU issues in the master pod when running with over 1,000 users and 2 workers. Did you run up against similar issues? How many resources did you assign to the master pod?
That's unfortunate to hear. No, we didn't, but I have to admit that our load, the load that we generated was not exceptionally high. I think we probably could have handled it all with just 1 worker. So it was not enough for the master to reach any CPU limits. So I really don't have any experience on that to share with you.
All right, I still hope it kind of answers maybe a little bit of the question. 2 left on Mentimeter. Can you scale up the workers dynamically?
Not that I'm aware of. You may be able to do something like smart with, executing these kubectl commands on certain triggers. I'm not sure. It's not like it's out of the box easy. No easy method, as far as I know.
All right, I just got the message. 1 minute left, so 1 question left. Or let's do just 1 question because it's the last one I have on here. What kind of reports can we get from Locust, and how do you save the history of all the runs?
Oh yeah, can I show something on my laptop for this?
Yes, I will step out of the image for no. Yeah, we will switch.
All right, just quickly on Waco. Like 10 users, so it speeds up. One important thing to note is when you're running these tests, you probably don't just want to be looking at these figures, but you want to be looking at the figures of your application that you're testing, like in Grafana. But there are some charts here, like how many requests per second am I sending, what are the response times, how many users are there, something about failures and exceptions, and you can download this data from the web GUI. There's just a tab for it. I think that's it for what I wanted to show.